I will be talking about what I think Rob started on Friday, automating health economic modeling reports through one R Markdown, which is, I think, more appropriate and trustworthy when it comes to creating static text, but also now augmenting that report for more contextual and narrative pieces of the report, such as the results section, conclusions perhaps, and so forth, where the text that we will use will depend on the numbers and the results that we're generating. Very briefly, I will talk about foundation LLMs for use in research. This is much broader than obviously report generation, but I think that will be relevant for the audience here to understand how good of a fit these systems are for what we do. Then I will pick up the conversation that Rob started, augmenting model report generation. And I would like to end with a couple of thoughts and ideas about what we may be able to do with these systems beyond report generation. Just to start with, we talk a lot about LLMs and what they can do, what they cannot do. And I think sometimes we lose the sight of their strengths and limitations, which really determines how they can be used in what context and what we can expect out of them. I think the strengths are quite well known and established now. They're really information processing. Obviously, they remove a lot of the coding or technical language from the interactions. They're really good at natural language understanding and producing text. They are very versatile. They can be molded into many different personas or task executors. Obviously, they're available almost every minute of the day. And then they have a very broad knowledge base because of the data that was used to train them. They know something about the world.
Oh no, we appear to have lost Baris. Rob, don't know if you've got a backup plan.
Yeah, I'm hoping that he will join in a second, and that will be relatively undisrupted. His slides are in the chat. There's a link there. So if you do want to have a look and kind of look at that slide in a bit more detail, I can put it up on the screen actually while we wait for Baris to rejoin. Let me do that. That might be useful. And maybe we'll give it a couple of minutes and then oh, there we go. So I think Baris was just going through this, and yeah, I'll leave that there for people maybe to read, and hopefully Baris is just joining us again, and can jump straight back in. Yeah. How are we doing, John? Can you see if he's rejoined?
No, not yet.
So this never happens in person. So yeah.
No, you've just got train delays.
Yeah.
Here he is.
No, I think
perfect. Good. Thank you. I'm not going to try and yeah. I've just shared the
screen.
screen.
I
just shared the screen, and the slides are in the chat, so people are having a quick look at the slide.
I will turn off my camera. 2 minutes before I joined the call, my internet at home just failed, so I'm connecting from my phone. I hope it will last for another 10 minutes so that we can go through this. So let me pick up where I was left. As I was saying, there are limitations of these systems that we need to keep in mind. Good news, I guess, on the limitation side is that those limitations are well known, and there are a lot of studies that are being conducted right now, and some solutions out there already to address them, which opens up use cases of these systems to broad application areas. Obviously, there needs to be, which I will talk towards the end, there needs to be more consideration and design and thinking through how these systems can be used for different tasks. But once we set up the right context and right environment, they perform really, really well on various different tasks that we carry out in HUR. So going back to the topic of the conversation, which is how we can leverage these tools for automating report generation. As I mentioned at the beginning, reports that we generate tens of pages, 50, 60 pages sometimes. A lot of these things in the report are static information, such as the input tables, result tables, some of the perhaps introduction section that we may want to plug in and so forth, which can be handled very well with our Markdown as we are building those models. But there are elements in there that really depends on the specific run of the analysis. So if we run a contra adaptation, the numbers change slightly, but they may also change the conclusions or how we're going to interpret those results and present. That becomes quite challenging with our Markdown type pre-programmed report generation, and those areas are exactly where these systems really thrive. So the one on the right is what Rob presented on Friday. So I would like to pick that up and continue building on that. I removed the earlier part of this diagram, but up to this point, Rob presented model setup, model run, we generate the results, we generate the static portion of the report, which is basically everything except the result summary and so forth. From here, the information is passed on the LLM, and LLM generates the summary, adds that to the report, and then the second LLM basically looks at the report in a more holistic way to understand what is missing, what is conflicting, or what is not accurate in terms of what we put in that report. But this is fairly flow. Again, we can leverage LLMs for task completion. If I present this slightly differently, and this is a very common use of LLMs, is what we are seeing here is input and output from an LLM. The input is our prompt when we're asking for a summary generation based on the report that we are feeding into LLM. And LLM basically generates that report response, which is the result summary, and then the task is done. This is, again, as simple as it is quite powerful because LLMs are capable of ingesting a lot of data and creating coherent summaries based on what the task is. This was an example in Rob's presentation, and I don't think Rob really got into the coding aspect of it, but I would like to highlight a couple of things in here as well. I believe this is available to everyone at the conference through a GitHub repo, but there are a couple of things to point out. One is, obviously, this is how we're defining the function, how we're calling the LLM summary function, which basically defines the type, the model, a specific model we're going to use, how to access that model, which URL to use, input path, output path, and so forth. The part that is, I think, also worthwhile mentioning is this is where we are extracting the text from the static report. We are putting this in a variable text, which then later on gets passed on to the LLM call, which I will explain in the next slide in more detail. But this is really collecting the information that we're gonna use to engage with LLM, passing that information to LLM, and getting the result from LLM, which is the previous diagram that I showed how the system set up. The query LLM is another function, which is where we have the details of how this interaction happens. Again, skipping the parameters at the top, this part, body, which is basically converting our list where our content is, into JSON format, which is most of the LLMs talking language, so to speak. It's a structured format of information. We basically transform the information into JSON format. Here we're linking the prompt, which is please summarize this document, with the document itself, which is the text. And then this is where we are passing that information to LLM, basically sending all that request through R-HTA, and we're getting the result from it. LLMs, when we engage with them through API, they have certain structure, and each model has slightly or may have slightly different structure of output. It is not only the response that is in that output, but a bunch of other information, such as number of tokens they used, whether they completed the task or not. If not, what was the reason for incompletion. So there are a multitude of different things that they generate as a response. Here we are basically saying, okay, let's extract the summary only, the response that we are interested in from the LLM broader response object, and then present that as an output. So this is, again, very typical way of using LLMs. If you think about the chatbots, this is somewhat similar to that. You send a question, request, you get an answer, and then that is all the interaction. Obviously, in chatbots, we have memory feature as well. As you build on your conversation, the system remembers the previous interactions and then sort of evolves into that conversation bit by bit. In this example, we have one request going into the system, output coming in, and then the interaction is done. So going back to the LLMs and what we can do beyond modeling with these tools, I like to use this analogy to explain the difference between what foundational LLMs do. And if we were to use them for very specific purposes, such as healthcare research or HOR, what else needs to happen to those foundation tools? Foundation models, LLMs, are almost like these wild beast beauties that are roaming freely in nature, like the wild horses that we have in North Carolina. It is a lot of fun to watch them, engage with them, and so forth, but there's really little we can do to convince them to run into a certain direction, stop at some place. They just do what they think is best. This is somewhat similar to these off-the-shelf foundation LLMs. If we were to use them in a very specific context to achieve a specific objective, we need a bunch of other things. We need to put guardrails around the system so that it knows where the playing field is, where it cannot go out, and so forth. We need to provide the appropriate context. We need to have the sort of the riders, or in this case, researchers, who will direct this effort. They need to have some examples, training before, and so forth. So there are multiple different things that we need to introduce into the mix so that what they produce is reliable, consistent, and reusable, which are the things that we really need for scientific research. So these things can happen, but obviously that needs thinking through and careful consideration of what the objective is, what are the tools we will need to define the objective of these systems, how we're going to trace how the system is performing as they take multiple steps. When we built these systems in such a way, the design options are quite few. The one that we just looked at, where we sent a report and got a summary of the result, is what I call basic interaction. This is one request to the system, one output from the system. And then, as you can imagine, this can get quite more sophisticated as we add different pieces to this. So change of thought or sequential workflows is where we send this request. The output of the LLM becomes an input to the next step for another LLM, perhaps. And then you can link all these different steps together to get a more sophisticated and more comprehensive response to a specific question. Another way is, which is how chatbots work, we can turn these systems into conversational systems where they can iterate on the responses per user input. So again, if you think about ChatGPT, you ask a question, you get an answer, you can have a follow-up question on that first one. And the response of the system will iterate on its response based on what we are providing as a feedback. You can imagine having multi-agent systems where each agent is responsible for a specific task, and the outputs of these tasks come together at the end to answer a bigger question. So you can think of this as typical research project flows. We set out a research question at the beginning. We land on a methodology to answer that question. We execute that methodology. We write a report after that. So you can ask different systems to handle different pieces as long as they're independent from each other and can be executed as such. Alternative to this, maybe even more a complex version of this, you can have these multi-systems, but now collaborating with each other. So it is not only putting the output of one system into another one as an input, but they actually converse about the outputs, the best way possible to move forward, and they iterate on each other's input till they land on a acceptable path forward. So this becomes really more and more autonomous thinking and decision making. And the last piece is where I think most of the leading companies are working right now, self-improving and adaptive systems. There are a lot of different components in here, which I will not get into, but the idea here is, can these systems evolve in their thinking as they carry out more tasks and applications from user feedback, from their own learnings, what worked, what didn't work. But there is, again, another area that a lot of companies, Google, Anthropic, and so forth, are working on to create such systems that are runs long time. Obviously, they need to keep that experience and so forth, but also evolve over time as well. With that, I will just come to the starting point. Again, looking at how capable these systems are, I think augmenting health economic model reports is one very obvious area of application. I would still encourage everyone to think through how to interact with these systems. API provides flexibility of what we do to output. This is one starting point. The code that you will have at GitHub repo, I think, will be a good starting point, but it can definitely get much more complex depending on the task that we're trying to carry out and how we design these systems to perform. I hope I was online throughout that talk.
You were.
But that is all. Okay, perfect. So I wasn't talking to myself. Thank you.
Yeah, don't worry. Okay, I've got a couple of questions in the chat for you, Baris, before we move on to our final panel. The first one's from Stephen. So do you utilize tools like system message, top P, top K, or temperature to further refine the responses?
Yes, all these parameters are relevant depending on, again, what we're trying to achieve. So that is another thing, actually, API provides added value. When we're using API to engage these tools, we can have control over all these different parameters, as well as if you think about LLMs as a function, like another R function, you can design when to call these systems to do exactly what task and when to call them off. But yes, parameters, how we use them are important. Most of the research-related tasks, I set the temperature to 0. So you really want deterministic results rather than coding.
Oh, that's a shame, Rob.
I think so. I think I know what Baris is about to say. So temperature generally will be set to 0 for the types of things we're doing, because what we want is the most deterministic answer. We don't want any degree of randomness in there. If you were, say, wanting someone to write you a poem, you might want it to be different each time. You might want to like get the LLM to write different poems and be really creative. For your summary of your model, you want it to be as absolutely like deterministic and simple as possible.
Right.
Stephen's got his hand up again.
Yeah, I'll
Yeah.
stop over time until it gets logged. That's correct, because I did a macro in SAS, and he's correct in what he was saying. It depends on temperature, or depends on the LMM. Temperature is obviously one, and then if it's a different LMM, sometimes they use top K, top P,
Yeah.
but regardless, it should be as conservative as possible, especially in this sort of clinical trial industry. So yeah.
On you mentioned about the system messages as well. So I think probably one of the really big things that we could do while developing these and integrating them into to the model pipelines and workflows is really try and write very like system prompt messaging and build up databases of these. So
Yes.
when you are trying to summarize a report, what should the system prompt look like? And so we've started doing that internally, just because it will improve things, and providing lots, for example, giving some examples of what you want out is useful. So I know Baris in his work is doing a lot of that as well. But I think that's something that the research community could do, is provide examples of what those prompts, those messages are like.
Exactly, 'cause
Yeah.
it almost hones the original prompt message. It's almost like the director of how you want the prompt to, or how you would like the prompt to respond accurately.
Yeah.
And
Yeah, so Paul, who I work with, uses these a lot, and he basically always just says, think harder as his prompt. So yeah. So go on, do whether Darren's got a question, but maybe Baris is Baris
Yeah.
joined again?
Go on, Darren. Do you
Ah,
want to
cool.
do
Baris is here. Baris
one
is
of the
here.
questions?
Yes, I can try to answer that very quickly. That's a good question. That is a huge area of research as well. There's the evaluations of these systems, how to trace, measure how they're performing. In this particular case, I think one way of doing that can be looking at the results, whether it is incremental cost, qualities, and so forth, and see whether the summary is actually carrying the right numbers. That may be one way to measure the accuracy of the summary. Obviously, the summary itself is quite a narrative text. There may be different ways to measure some of these elements in there as well. But there is again, measurement is very task specific. What we're asking system to do, then we need to sit down and think through how we can measure the accuracy or the performance of that system against that task. There's no set rules, unfortunately.
Okay, thank you.
I guess a follow-up question that's basically directly following on that is, what's the appropriate place to actually draw a line in the sand for automatically populating sections within one of these reports? Because LLMs cannot and will never be able to think. So should we always be sticking strictly to summarizing things and pointing out inconsistencies, and just completely avoid any sort of critical inference, causal inference, anything actually requires a human to really think about what's been presented?
That is great. One point that I forgot to mention as I was rushing through my slides, in that increasing complexity slide, just because we can build complex systems doesn't mean we should build complex systems. There's a trade-off between complexity of the system and the control that we have over the system. Every single time we are bringing LLM in to perform a task, because they're probabilistic machines, we're opening up a risk that we will not get what we need, or they will go off the rail or do something else. So when we're, again, thinking about how to use LLMs, this is why I really prefer APIs, is that I can very well define what LLM needs to do and what it cannot touch in the overall process. So for instance, if I want to, going with the report example, if I know exactly what I'm going to put in the method section, the introduction, the data tables, etc., and they're set, very much like what Rob present, I wouldn't ask LLM to create those sections for me, because there's a chance that they will miss a number or what have you. And that is a static thing that we can do very easily with direct programming. If I need to get into more sort of ideation, summarization of documents that are large volume, then that is where I can leverage LLMs more and more, with still some well-defined task descriptions and guardrails and so forth. So again, it is not a one-size-fits-all. It is very dependent on the task, what risks we are willing to take, and obviously also building systems that can QC and validate the output of these LLMs in the system as well.